Okay guys, this is the second video in section 6.3. I just want to talk a little bit first before I move on with this next video. So just to kind of answer, I'm guessing you guys had a couple questions. Like I said in the last video, I said you might not understand this right now, but hopefully eventually you'll get to that point where it makes sense. We still might not be to that point, so I want to try to get us to that point. So you might have been asking, let me go over two questions that I think would have been common here. The first one is, when do we know to choose integration by parts? Okay, and I kind of talked about that in the last video. You should pick integration by parts to use when you've got multiplication of two variable terms. All right, so that's a good opportunity to use integration by parts. Now, with the other question, what I was thinking that you guys might be asking is, why do we let u equal x in this case, and why do we let dv equal cosine x dx? So that's what I wanted to talk about in this video. I'm going to have some things for you guys to write down, and also we're going to talk about a hierarchy of what to let u equal. Okay, so what should be the first thing to look for when we're letting u equal something. So let's get this started. The way to remember this, let's talk about the hierarchy first here. What should you choose first if you have a choice with these types of problems, integration by parts. So here we go. The way to remember it is lipet, L-I-P-E-T, lipet, I guess. So this is the order that you should look to let u equal. All right, so what we mean by lipet is this. Let me scroll down. So L is going to represent a logarithm. So if you have a logarithm in your integral, you're going to want to let u equal to that logarithm. Okay? I is going to be an inverse trig function. This is something that I don't see us working too much with because we really didn't spend too much time working with inverse trig functions with antiderivatives. Or sorry, with derivatives, I should say. P represents a polynomial function. So in the last case, well, we'll talk about the last case in a second. So P is a polynomial function. E is an exponential function. And then T stands for a trig function. Okay, so a trig expression or function, whatever you want to look at it, however you want to look at it there. So I kind of drew an arrow to this because I wanted to talk about the last example that we did. So guys, we let u equal x because x is a polynomial function. That comes first on the hierarchy here. All right, now again, this is a rule of thumb. I'm not saying you have to do this every time, but yeah, it's going to make it a lot easier if you use that hierarchy. Okay, so yeah, that's a polynomial function. Cosine's a trig function. It falls lower on the list here. Trig function down here. Polynomial function is right there. Okay, so with that being said, let's try to let me write this. Let's write this down. The reason we do this is because of this. So write this down as well. So we want u to be something that simplifies when differentiated, and we want dv to be something that remains manageable when integrated. Okay? So we want it to be simpler when we differentiate. We want u to be simpler when we differentiate. So when we take the derivative, okay? And we want dv to is something that it might not be simpler, but it's at least manageable that we can work with. So let me kind of go back to that lipet and kind of explain also the previous example and explain why we did this. So pause this if you need to write this down. I'm going to be going back to this. So guys, when we take the derivative of x, that becomes a lot simpler. It's just 1 dx. Okay? Not that x is too complicated, but it's simpler, 1 dx. Now, think about cosine x dx. When I take the antiderivative of that, it's still manageable. It doesn't become simpler, hopefully you see. So that's why trig functions fall the lowest on the list. Okay? So it's still manageable. When we take the integral of cosine x, it was sine x. Okay, so that kind of gives you an idea. That's why trig falls so low on what to let u equal. So that's true. So write that down there, and I'm going to move on. All right, this right here. So guys, kind of another note to write down here. The goal of integration by parts is to go from an integral, which is the integral from u dv, that we don't know how to evaluate, to an integral, which would be v du, that we can evaluate. Okay, so write this down, pause it if you need to. I'm going to scroll down so you can see the rest of it. Here we go. Thus, integration by parts doesn't always work. Okay, it's not always going to be the best option, but sometimes it is, and that's why we're going to work on here. That's why we're going to do some examples. All right, so I think I've got one example here that I want to do in this video, and then we'll probably have another video that we'll do some more. So let's go ahead and do this. So how about this one? We'll start with something. This is kind of simple, but that's all right. We'll see what we can do with it. Okay, so we got x times e to the x dx. All right. Okay. So here we go. Let's talk about this. Well, guys, you should see using limit here. You should tell which one we're going to have to use. All right. You should be able to determine which one. When I say that, I mean which one do we let u equal. I can't remember what I did with my marker. It's not in my, oh, it is in my pocket. Here we go. Okay. So we should let u. Everybody should be yelling at me right now. U should equal what? Well, we don't have a logarithm, we don't have inverse trig. We've got a polynomial, so that's what we should let u. U should be the polynomial function, which is x. So that means dv, we're going to let the other stuff, and this over here, so we're going to let this be u. Now let me do this in a different color. And this is going to be dv. So we're going to let dv be here. Go back to black here. So dv is going to equal e to the x dx. Okay? So when we do this, we let u equal x and then dv equal e to the x dx. So what we need to do to use the formula is we're going to have to figure out what du is going to equal. Well, we should be able to do that one real quick. What's the derivative of u with respect to x? Well, that's going to be derivative of that guy's 1, but if we want to find just du, it's going to be 1 times dx. So it's going to be dx. 1 times dx is dx. Now, to go backwards here, we've got the derivative of v. We want to figure out what is v. All right, so what did we have to take the derivative of to get that as our antiderivative? Sorry. Yeah, to get that as our function. Sorry, what did we have to take the derivative of to get this as the derivative? Well, if you think about it, the derivative of e to the x is e to the x, so that means the antiderivative of e to the x is still e to the x. All right. So hopefully you remember that property. Okay. So we've got these written down. Now all we got to do is apply the formula. So let's do it. Let me write down the formula so I don't have to keep flipping back. So I believe the formula was u dv, the integral of u dv, is going to equal uv minus the integral of v du. Makes me think of voodoo, VDU. Kind of, I guess that might be a way to remember it, voodoo. Okay, so this is going to be the integral of x times e to the x dx. And we said this was u and this was dv. So this whole thing was dv. Okay, so let's go ahead and start plugging stuff in. So what did we say u is equal to? Yeah, u is equal to x. What did we say v is equal to? It's equal to e to the x minus the integral. What's v? Well, it's still e to the x, right? And what's du? Well, du is just dx, so that's nice. There it is. Okay. So now we just got to do a little bit of work. We got to figure out what the integral is of e to the x dx. Well, that's pretty easy. We've already done it, really, haven't we? Taking the antiderivative of e to the x is just e to the x. But in this case, we're going to put a plus c. So this is going to be x e to the x minus e to the x. The integral of e to the x is e to the x, and then we got plus c. That's our answer. Now, what you could do, this is just an option. If you wanted to, you could rewrite it like this. These two terms both have an e to the x in common, so we could factor that out. So either one of these would work. Hopefully that made sense when I factored it out. When I factor out an e to the x from this term, I'm left with x. When I factor out an e to the x from this term, I'm left with -1. Okay, so whichever one you prefer there, circle that as your answer. All right, so let me show you how to check this answer. This shouldn't be too bad. Again, you guys should know this. How do we check to see that that's the right answer? Well, this was the antiderivative, wasn't it, of our original function? So if we take the derivative of the antiderivative, it should give us the original function. So let's take the derivative of this guy. Okay, so let me write that out real quick. I'm going to rewrite. I think this will be easier to, maybe not. Let's take the derivative of this guy. Okay, you could look at either one of them, but I'm going to take the derivative of that one. All right, so let me rewrite it again. So it's going to be x times e to the x minus e to the x plus c. We want to take the derivative of it. So off to the side here, this term right here, it's a product, right? So we have to use the product rule. So use ABBA. So A is going to be x, B is going to be e to the x. A prime is going to be 1, B prime. What's the derivative of e to the x? Well, it's just e to the x. Okay. So we got that. And then we need to do ABBA, A prime B plus B prime A. So we got 1 times e to the x, which is e to the x, plus b prime a, which is going to be e to the x times x, which is the same thing as x times e to the x. So hopefully that made sense. If it didn't, rewind that, if I was going too fast. So we've got e to the x plus x times e to the x. Now, we haven't taken the derivative of this one yet, so we just took the derivative of this guy. And we want to take the derivative of negative e to the x. Well, the derivative of negative e to the x is negative e to the x. And then again, what's the derivative of a constant? Answer, 0. So we don't have to worry about putting plus 0. Okay, doesn't something cancel here? Gone, gone, what are we left with? There it is. Okay, so that was our original function. Let me just look back up the original function. Isn't that what we started with? Sorry, I know it's kind of messed up here, but it was x times e to the x dx. Alright, so that was that example. Next video, if I can get to it, different examples we'll look at. Thanks.